equidistant means that you are the same distance away from a figure. And we're going to be talking about a point, but same distance is your keyword. Okay? So here's your theorem. If in a plane, if a point lies on the perpendicular bisector, so we're looking at this line here, CP. The line CP is a perpendicular bisector. We know that because it's marked with a right angle and two congruent markings. That's what you should have had on your picture that you drew. If it lies on the perpendicular bisector like C does, then it is equidistant from the endpoint. So C is the same distance away from A and from B. And so CA is equal to CB. Okay, converse, if you remember converse, you just take the statement and you flip it around. So we take our if then, we flip it. So what would my converse be of this if we flip that? Or at least what would it start with? If Cooper, what would it start with? So we're taking this statement, we're flipping it around.
Oh, you're asking me?
Yeah, I'm asking you.
Oh.
So what would the next one start with, the converse? If?
BCA equals C.
I'm talking about this one.
Oh. Equidistant.
Yeah. If it's equidistant, then it's on the perpendicular bisector. So we just start with the second part of it. If the point is equidistant, I need a new stylus. It is equidistant from the endpoints, then it lies on the perpendicular bisector. That symbol that you just saw me draw, that means perpendicular. So if we can prove that these two pieces are the same in measure, then we can say that C is on the perpendicular bisector. Okay, two examples. One, we are told that AC is a perpendicular bisector. You need to find AD. So since we know that it's a perpendicular bisector, which two, like we know that these two, BC and DC, obviously those are congruent because it's bisecting that. But what else do we know to be congruent, Aiden?
AB and AD.
Yeah. So these two would be equal. AD, AB. And so you can set them equal to each other in an equation. So I'd say 7x minus 6 equals 4x. And we need to go ahead and solve that equation if you could do that. Just a reminder, I would not subtract 4x because then you have 0 on that side. I would subtract 7x instead. That way, I know it's a little bit weird looking, but it'll still work. Negative 6 equals negative 3x, and so if you divide by negative 3, what is x equal to? 2. But look back, you were asked to find AD, so you're not done. We know that AD equals 4x. So you're going to substitute 2 into x and get what your measure is for AD. Be 4 times 2, which is 8. So AD equals 8. Remember, if we're using the equal sign, we do not put that segment marking on the top. Okay, and the next one we're going to probably use a converse. So in the diagram, we know that KN is a perpendicular bisector of JL. So we know it's bisecting JL, so I would mark that right away. What segment lengths in the diagram are equal? We know one set. It would be JN and LN. There's another set we know for sure as well. Tori, what would the other set be? One more set of congruent segments. You say it again. M? We don't know that. Well, we do, because they're equal right here, so that works, yes. Okay. So then there's actually one more. Yeah, these two. And that's because we know it's a perpendicular bisector, so we know that K is equidistant from J and L. Okay? And of course, we're told that both of JM and LM are 13, so those are also congruent. Is M on KN? So if you extend KN, will M be on it? Can you please discuss with the person next to you? What do you think and why? Okay. Brennan, what do you think? Is M on KN? How do you know?
You get points J and L. J is 13 and L is 13.
So equidistant, and so you can say is on perpendicular bisector. Good. So that's using the converse. So yes, and you need to explain because M is equidistant from J and L. All right, we're going to do angle bisectors next. So I hope you're seeing what we're doing this unit in this 3 days. This is, I hope, not bad. Should be one of the more simple things we've done. It's just properties of this stuff. Okay, angle bisector. If a point lies on the bisector of an angle, and notice it's marked, you have to mark that the angles are congruent. Oh, hello. And you see that, slowly, right here. If a point lies on the bisector of an angle, then it is equidistant from the two sides of the angle. So these two are congruent. Okay. The converse then, flip that around. If it's equidistant, then it lies on the bisector of that angle. So same type of thing. Equidistant from the sides of the angle. Then it lies in the perpendicular bisector. Oh, sorry, on the angle bisector. Whew. Okay, if you look at your next example, find the measure of CBE. You guys can say it out loud. What do you think CBE is probably going to be? Yes, 31. But I need someone to explain how you actually know that. Like, you do have enough information to prove that to me, but how do you actually know? And if you think you know, you can raise your hand. Cooper, how do we know? How do you know it's an angle bisector? How do you know? It looks like an angle bisector.
It's not that long.
Well, CE and ED are essentially.
Ah, because this is equidistant. It's equidistant, and so E is on an angle bisector then, so yes, this is an angle bisector, so yeah, that is 31. So you have to get some kind of information out of it first before you just go ahead and assume that it is. So measure of angle CBE does equal 31. Because you have that they're equidistant, so E is on the bisector, or is on a bisector. So last one, what value of x does P need to be? Or so for what value of x does P lie on the bisector of angle J? Bonnie, what's the equation I should write for the last one? Because we need those to be the same length. So that way P is equidistant, so we know it's on the bisector. So set them equal and solve. I'm going to subtract x. That would give me, oh gosh, x minus 6 equals 1. That's wrong. I'm sorry. I should say x minus 5, right? And then add 5, and you should have x equals 6. And that's all it asked for, so you're done. If you could please explain to me in your summary, what do you know to be true about perpendicular and angle bisectors based on the properties, theorems we talked about today? And then I will